Welcome to Internet Infrastructure Explained.
Have you ever wondered how large organizations manage to keep different departments, like sales and engineering, completely separate on the same network infrastructure? Imagine needing individual communication channels for each, even though all their computers plug into the same physical switches and cables. How can a single wire carry traffic for completely distinct virtual networks without ever mixing them up? Virtual Local Area Network, or VLAN, trunking isolates traffic interswitch by using a tagging mechanism, typically 80.1q, which adds a small header to Ethernet frames. This tag explicitly identifies which virtual local area network the frame belongs to, ensuring that only devices configured for that specific virtual local area network can process the traffic. The 82.1q standard is key to this isolation. When an Ethernet frame leaves a switch port configured for a specific virtual local area network, and that port is an access port for an end device, it is typically untagged. However, when the frame traverses a link between switches, configured as a trunk port, the originating switch inserts an 82.1q tag into the frame. This tag contains a virtual local area network identifier, a 12-bit field, which allows for over 4,000 unique virtual local area network identifications. The receiving switch reads this tag, determines the virtual local area network, and then forwards the frame only to ports associated with that particular virtual local area network, effectively creating a dedicated virtual pathway across the shared physical link. This segmentation ensures traffic from one virtual local area network never leaks into another. In practice, when a frame arrives on a trunk port on a destination switch, that switch examines its virtual local area network tag. If the tag matches one of the virtual local area networks allowed on that trunk link, the switch processes it. It then intelligently decides where to forward the frame, to another trunk port if it is headed further into the network, or to an access port matching the virtual local area network if it is destined for an end device directly connected to that switch. The crucial point is that the forwarding decision is always based on the virtual local area network identifier carried within the tag. If a frame arrives on a trunk port without a tag, it is typically assigned to the native virtual local area network of that trunk, or dropped if no native virtual local area network is explicitly configured. This precise mechanism prevents untagged traffic from interfering with the securely tagged virtual local area network traffic. An interesting nuance here involves the concept of the native virtual local area network. This is the virtual local area network whose traffic is transmitted untagged over a trunk link. It acts as a default for any untagged traffic that might arrive on the trunk. As a best practice, network administrators often configure the native virtual local area network to be an unused virtual local area network, or explicitly assign it to a dedicated, isolated virtual local area network. This helps prevent potential virtual local area network hopping attacks, where an attacker might try to send untagged frames that could then be accepted by devices on a commonly used or default native virtual local area network. Another advanced attack, known as a double tagging attack, exploits the native virtual local area network by crafting frames with to 80.1q tags to bypass intended isolation, highlighting the importance of careful trunk port configuration. Ultimately, virtual local area network trunking, powered by the 82.1q tagging standard, is a foundational mechanism for extending virtual network segmentation across multiple physical switches. It creates distinct, isolated broadcast domains over a single physical wire, optimizing network resources and significantly enhancing security by preventing unauthorized cross-virtual local area network communication. This powerful capability makes network management much more flexible and scalable, adapting to the dynamic needs of modern organizations.
If you love understanding how the web works, like, subscribe, and stay connected with us.